subtracting today and then multiplying and dividing tomorrow. And then we'll do something called rationalizing, which you've never seen before. And then equations, then we're done. That's it. Teeny tiny little unit. So let's go all the way back to grade 9 math. And I want you to simplify that top expression. It's a pretty good assumption. So tactile people might be circlers, visual people might underline, auditory people might not care at all. Put the x's together, 3 minus 2 gives us. And then we have 5y and 4y, put those together and we get. Okay, so you did that last year, not a big ideal. Same thing now with radicals. So you can't add a radical x, for example, with a radical y. You can't add them together. So if we have 3 radical x minus 2 radical x, how many radical x's do we have? 1 radical x. And we have 5 radical y and 4 radical y. How many radical y's do we have? Don't blow the suspense, come on. Do you see the similarity? So they're just like terms, and we're just collecting them like we collect variables. Okay, so let's take this one when there's numbers underneath instead of just x's. So 3 root 3 minus 2 root 3, how many root 3's do we have? And 5 root 2 and 4 root 2, how many root 2's do we have? 9 root 2. And whenever we have the word note, it's clearly going to be very important, so I'm going to highlight that. And I'm going to write it in red. That's visual. Visual people do that.
Amnesia or something. I don't know.
Note, the radicands do not change. What's a radicand?
It's the number that's on the inside of the red.
Mm-hmm. So here we had a root 3, and here we had a root 3, and in the question we get a root 3. Okay? So we don't change those radicands, they just stay the way they are. Same with we had 5 root 2, 4 root 2, we ended up with 9 root 2. Didn't change the radicand. Grab your paper. Can't spell, subtracting. Any other left brains? They would understand that really I want to throw that paper away and start again because I spelled it wrong. It's a left brain thing. So we're going to start with a couple examples, then we'll get down to the method. We're starting with the easiest questions you're going to see. So a root 3 plus 4 root 3. If in your head you want to see these as x's because your brain's used to adding x plus 4x, then start that way. So your brain can see x plus 4x as how many x's? 5. Same idea. Root 3 plus 4 root 3 is? 5 root 3. Okay, so coefficients go together, radicand didn't change. Same thing with cube roots this time. So a cube root of 7, minus a cube root of 5. What do we do with those? So if we didn't change the radicand here, what do we do with this? So think in your head this is just like an x and a y because they're different radicands. So what would we do with x plus y last year? How would we combine them? Can we make that xy? No. Can we combine an x plus y? Only if you know what they are, but like this with algebraic terms, can we combine an x plus y? it would just be x plus y. So this is already simplified. So when can you combine radicals and when can you not? When the radicands are the same. Okay, so let's put that in our method box, step number 1. Combine terms with the same radicands.
Notice the radicands do not change.
Still doesn't change.
The radicands don't change. Okay.
Nope.
I didn't get that down.
This out of the way. Apparently I thought the last example was 3. Example 3. Radical 3 minus 5 radical 2 plus 6 radical 2 minus 7 radical 3. This is just like with variables, so this would be like x minus 5y plus 6y minus 7x. Okay, same idea, we have 2 different radicands. Yep, you're a step ahead of me. So again, tactile or visual people sometimes like to circle to group. So if that worked for you with doing algebra, then do the same thing here. So 1 root 3 minus 7 root 3 is negative 6 root 3. And then minus 5 root 2 plus 6 root 2 gives us positive 1, which we don't need to write root 2. Do you see the link to algebra in grade 9? But wait, let's step it up. Take a look at number 4. So what's different about number 4 that we haven't seen yet in 1, 2, or 3? Maybe think about what we did on Friday. Different radicands. Well, we had different radicands up here. So what did we do on Friday? I know it seems so long ago. Flip back in the note package. What did we do on Friday? What did we do on Friday? And what did we call that when we converted it to mixed radicals? It was in brackets in the notes. We called it something. Simplifying, that's the difference in number 4. If you go back and look at 1, 2, and 3, they were all simplified already. These guys are not. So just make a note, you might have to simplify first. That's why we learn simplifying, because in order to add and subtract them, they have to be simplified first. So when you look at number 4, you're like, oh, well, radicands are different. We can't add them. But that's why we have to check the simplifying first. So let's just look at the cube root of 54 first, not worrying about the second part of the question yet. Okay, good review from Friday is how do we simplify radicals? Prime factorization, if you like that method. If you didn't, then do it a different method. Okay, so what do you want to break this into? Okay, I heard 6 times, what did I hear 6 times? 9 would work, 27 times 2 would work. It'll all get you down to the same at the end. 27 we can break down into. And then I heard somebody already say the 3s. So remember, there's not one right way to prime factor as long as at the end you're 3 to the 3 and then times 2. And so just like Friday, we're going to split the 54 into the 3 times 3 times 2. If your brain would rather see 27 times 2, that's fine as well. And then we can break this guy up into cube root of 3 to the 3 and cube root of 2. And what happens with a cube root of 3 to the 3? Just becomes 3. And then I've got that cube root of 2 hanging around in the back. Okay, and let's do the same thing with the cube root of 16. What would you like to break 16 into? And then? And there's 4 2's, but how do we want to group them? 2 to the 3 and 2. And again, if your brain would rather see 8 times 2, that's fine as well. We can start to skip some steps if your brain will let you. If you still want to do them all, that's fine as well. But you don't need to actually write the step where you break them up. If you can see right away what's going to happen with the 2 cubed when we take the square root, you can jump right to the answer. So what's going to happen with the 2 cubed? It's just going to become 2, and then what's going to be left? Cube root of 2. So I'm just skipping this step here. If your brain wants that step, then put it in. But if your brain lets you skip it, then skip it. So the reason we simplify, because look what's going to happen now when we put the 2 pieces back together. We had a 3 cube root of 2. And was it plus or minus? It was plus a 2 cube root of 2. What do you see now? Exact same radicand. So when we combine them together, all of this equals 5 cube root of 2. That's why we learn to simplify, because it needs to be simplified in order to add them together. Okay, so the stuff on the left is exactly what we did Friday. The only thing I'm adding today is just adding together the common radicands. How are we feeling? Good? Meh? Abby missed Friday, so probably you're like, whoosh. Yeah, that was Friday. Okay, let's look at 5. A 75, b to the 5. Now, right brains, is that a b squared, or is that a square root of 32b?
B squared.
How do you know it's a b squared? What was the little trick I taught you Friday?
Because the little hook is not right under the 2.
Good, and with a square root, would we ever write the 2 that's there? No, so we know that's a b squared times, and I'm going to leave a little space just so the right brains can see it, times 32b.
That makes it even easier.
Okay, we have to simplify. Let's start with the 75. So you can prime factor. If your brain can already see the perfect square, you can do it that way as well. A lot of people can already see 75 is what times what? 25 times 3. Okay, so if you needed to prime factor to get it, that's fine as well. So you might have a 5 squared and then a 3. How do we want to group the b to the 5? So how do I want to split that up to be able to do a square root of a b to the 5? B to the 4 times b. You could also split it b squared, and b. As long as you've got even exponents, you're fine. Now again, if you want to write those all as separate radicals, you can. What I just do is I tend, because I'm visual, tend to circle the ones that I can do the square root of, and then I just do them right away. Again, if your brain doesn't like that, then you can write them all separately. So my brain goes, okay, square root of 25 is 5, and square root of b to the 4, b squared, and then I just throw together everything that's left. So what did I not circle under there? A 3b. Okay. Again, if you like to show all the steps, show all the steps. There's nothing wrong with that. Okay, what do I do with this b squared in front of the second piece? What do I do with him? Well, when you don't know what to do with something, what's always a good way to try? Just leave it. Just leave it there and don't worry about it for this point. Okay, let's worry about this 32b that's behind it. Again, you can prime factor, or if you can start to see the perfect squares, you can just pull them right out. 32 is what perfect square times what? 4 times 8, neither of those, or 4 is a perfect square, but there's going to be a bigger one. 16 times 2. So again, you don't need to just know that. If you prime factor it, you get the same thing. Okay, so I'm going to leave my little b squared hanging out front because I don't know what to do with them yet. Again, I like to circle the things that are perfect squares. If you're not visual, don't circle it. Square root of 16 is 4. And then we just leave everything that's left under that root. So a 2b is going to hang around under that square root. Now I'm just going to clean this up because we would never write a b squared times 4. How would we write that? What kind of order would we put that in? 4b squared. So I've got a 5b squared root 3b. And I've got a 4b squared root 2b. Or not to be. That was funny. Now what? Okay, so how do we know when we can combine radicals or not? They have to have the same radicand. So you're always checking the radicand. Can we add these? So there's our answer. We're done. That's as simple as it can get. So there's the final answer. How are we feeling? So-so? Okay, I got a 3b and then a cube root of 40b minus 2 times a cube root of 135b to the 4. See, that would make applied and essentials kids cry. That's why you are pre-cal kids, because you can do this.
Yay, pre-cal! Although I doubt my mom would have been saying, the same thing at my age.
Okay, 3b, I'm just going to leave him up front because I don't know what to do with him. He's just going to hang out there. What I need to look at is that 40. So again, we can prime factor, or if you can start to see the perfect cubes, you can do it in one step. What are your perfect cubes? Well, in general, so 1 times 1 times 1 is 1. 2 times 2 times 2, 8. 3 times 3 times 3, now you're up, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. Those are the most common. I'm going to repeat them in case you want to jot them down. Those are the most common perfect cubes are 1, 8, 27, 64, and 125. Again, you don't need to know them. You could prime factor. We're just trying to save a little bit of time. So if you memorize those perfect cubes and you look at 40, you should be able to see one of those is a factor of 40. Which one? 8. So I'm going to break it into 8 and 5. 5. Again, you can prime factor and you're getting the exact same thing. We're just trying to save a little bit of time here. Okay, which of those can I take the cube root of? The 8. Okay, so 3b still hanging out front, not worried about him yet. What is the cube root of 8? And then I'm just going to smush together everything that's left, so I have a cube root of 5b. Now we're just going to clean up this coefficient. So if I have a 3 and a b and a 2 and I'm multiplying all of those, what do they become? 6b and then cube root of 5b. Okay, the second term, I'm leaving that negative 2. And now I'm going to do the stuff with the radicand with the second cube root. So 135. Factor of 5. Okay, so we're looking for 1, 8, 27, 64, 125. And again, if you don't know it, you can prime factor. So what are the factors that's in there? It's 27 times.
I've got both these terms are cube roots, aren't they?
Yes.
Okay.
So I'm just going to split into negative 27 and 5. Again, you don't need to know that. You could prime factor if you're on your own. What do I want to do with b to the 4? Split it into b to the 3 and b. So negative 27 I can take the cube root of. B cubed I can take the cube root of. Okay, so leaving that negative 2, I'll worry about him in a second. The negative 27 cube root, well, what happens with that negative? What happens with a cube root and a negative? Yeah, it's just a negative, just tags along. So the cube root of negative 27 is, and I'm just going to make sure I'm bracketing it, otherwise it might look like a subtraction when I take it out front. And then the cube root of b cubed is b. And then just smushed together the stuff that's left, I've got the cube root of 5b. Again, those brackets around the negative 3 are important, otherwise it looks like a subtraction. Just like last term, I'm going to just smush all that together. I've got a negative 2 times a negative 3 times a b. And we want to make sure we're putting that positive 6b in there. Does everyone see why it's positive?
Because 2 negatives.
Because 2 negatives. And then we check our radicands, and unlike the last example, woo, they're the same. So what does that tell us if we have the exact same radicands? We can combine them. So if I have 6b and 6b, I'm just going to add those together. How many b's? 12b times the cube root of 5b. That's as hard as they're going to get.
Okay.
Except here it becomes an addition question because of the negative negative.
Yeah.
Number 7. Ugh, word problem. It's okay, they don't scare us. What's the first step with any word problem? Read to. No, that's step 2, read to. Read. Don't overthink it, don't stress about it, just read it, just put the context in your head. Now take a big deep breath if you're feeling stressed, and now we're going to go in and try to pick out the key stuff. Only one sentence. What do you want to highlight? Blah, 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 blah. You did a great job of picking out the keywords there. Okay, so perimeter of a square, side length of this stuff, simplest form, okay? What's the first thing we typically do with a word problem if we can? Draw it out. So especially for visual people, draw it. What are we going to draw? That's true. When in doubt, draw it out. What do you know about a square? What's a characteristic that's important here about a square? Ooh, it was almost in stereo. Do we know the side length? Okay, what is it? How do we find perimeter of any kind of object? Add up all the sides. So if I have one cube root of all of this stuff, and I'm going to have a second, and I'm going to have a third, and I'm going to have a fourth, perimeter is going to equal 4 times the cube root of 27, w to the 4, g to the 8. You're thinking, well, that was pretty easy. That probably tells you you're not done if the question is super easy like that. What's the key for this? Simplest form. So now we need to simplify. Okay? Thoughts? So I don't know what to do with the 4, just leaving him up front, not worrying about him. Now we're going to break up this inside. What do you want to split it into? Okay, we're dealing with a cube root, not a square root, though. So if you look at those little numbers that we just wrote down for cube roots, what do you see? 27 is 1, so we can just leave him by himself because we're going to be able to cube root him in a second. So really what we're doing is 27 times 1, but we don't need to write that. How do you want to split the w? I heard a w to the 3 and a w. How do you want to split the g? G6 and G2. Why did we put G6? Because it's divisible by 3. You could put G3, G3, and then G2. You can split it up that way as well. Okay, so we can cube root the 27. We can cube root the w to the 3. We can cube root the g to the 6. Waiting?
We can't. I don't think we can, because 6 isn't a cube root.
But remember, when you're dividing, it just has to be a multiple of.
We're dividing. Oh, whoops.
Okay, so 4 hangs around up front, not stressed about it yet. Cube root the 27. Cube root the w cubed. Cube root the g to the 6th. And again, if you want to make a note, the squared comes from 6 divided by 3. Okay, leave the cube root and leave anything that we didn't circle or anything we didn't touch, so what's left under that cube root? I heard a WG2. And the last step in all of these is now just simplifying up all this crap that's in front. It's multiplying, so I have a 4 times a 3 times a W times a G squared. Ooh, it's almost in stereo. And what's left? There's our final answer. Coach is done. You're now going to practice some on your own. If you were kind of like, during the notes, that's okay. Work with someone then. So find someone else that's not too sure or someone that is really sure. You're going to flip open the workbook, page 114. You're going to dig out the calendar to find the exact questions. And then you are going to pick a specific question. What question are you going to pick?
Scary one.
Scariest one. Probably a word problem. Probably has lots of variables and stuff in it. Why do we pick the scary one first? Get it over with. Exactly. So there's all these people. So again, if you're like, on this, work with someone. That's fine. Yes. For that 45 minutes for homework today. What do you have that is a cupcake? Natasha, what is a cupcake?
Oh, it's a little eraser line sharpener thing. Yeah, my little brother Liam, he got it at this sort of book fair sale thingy at school.
Oh, cool.
Yeah.
He gave it to his sister.
No, he didn't really give it to me.
I should tell her.
I suppose technically yes, but I mean, he really cares. He's about to fix it out. And he didn't really care.
And I was trying to control it, but Emily sitting right beside me, she just lost it. She started to laugh. And I
Okay, what are you guys
couldn't
talking
help
about?
it.
Mr. Coggins, or French teacher.
Who's your French teacher?
He's a teacher.
Oh, okay, okay. This is Mr. Okay, yeah. Okay. Which I taught Miss B as well. Both Mrs. B, School Gate, Mrs. B's and Farms. Yeah, we're a year apart in school.
I broke it.
Except I just don't know what to work.
And they were both the top IB winners, one right after the other.
I should tell Mr. Hodges, but
Mr. Hodges, we were talking about before.
It's gone. It's. I don't think somebody stole it. I think what happened is it snapped off the string and they threw it out by accident. But I know, and that sharpener it's bad. It's so bad.